A second principle for solving equations concerns multiplying. The multiplication principle states for any real numbers a, b, and c, with c not equal to 0, if a equals b, then a times c is equal to b times c. We've maintained equality by multiplying both sides of the equation by the same number. And let's look how we use that. In this first example here, we have x being divided by 6. The opposite operation of division is multiplication. So to solve for the variable x, I'm going to multiply the left side by 6, and to maintain equality and following the multiplication principle, I will multiply the right side by 6. Just to illustrate how the 6's cancel out, 6 is understood to have a denominator of 1. When you multiply fractions, you multiply numerators and you multiply denominators, and you can cancel a common factor. In this case, we have 6 in the numerator and 6 as a factor in the denominator, which is equivalent to a 1, leaving 1x in the numerator over 1, or just x, and simplifying on the right, we have a value of 12. So the solution to this problem is x is equal to 12. In the next problem here, we have x being divided by -2. We always want to solve for a positive variable, and to undo a division, we will multiply both sides by the same quantity, and in this case, I'm going to multiply by a -2 on the left and the right using the multiplication principle. Again, like the last problem, to help see the cancellation, I'll put the -2 over a denominator of 1. A negative divided by a negative is a positive. A factor of 2 in the numerator over a factor of 2 in the denominator cancel out and are equivalent to a 1. That leaves 1 times x over 1, which is x. And on the right side, a positive times a negative is a negative, and simplifying the multiplication, we have a -14 for a solution. In this next problem, the variable is being multiplied, and perhaps you would consider division. Rather, we can use the multiplication principle and multiply by the reciprocal of this number that the variable is being multiplied by. The reciprocal of 5/3 is 3/5. To maintain equality, we'll multiply the right-hand side by 3/5 as well. On the left, we can see we have that common factor of 3 in the numerator and the denominator, as well as the 5, which cancel out, leaving a 1y. So we have y by itself. And to simplify the fraction on the right, again, I'll put a denominator of 1 for 20, looking for a common factor. Since 20 can be broken down into 5 times 4, in other words, it has a factor of 5, we can cancel out a 5 factor in the numerator and the denominator, leaving a 4 in the numerator, since 5 times 4 is 20, and again, the 5 is canceling out, leaving numerator values of 4 times 3 over 1, or an answer of 12 for the solution.